At the edge of imagination, a question lingers like a shadow. What happens when time itself runs out? Picture a universe stretched thin, galaxies adrift in a darkening sea, stars extinguished one by one until only silence remains. The story of existence, written in the fire of suns and the birth of worlds, seems destined for a final, inevitable period. Yet science dares to ask, must it end this way? Across the void, forces we can scarcely fathom continue to shape reality. Black holes evaporating over unthinkable eons, particles fading into nothingness, the cosmic clock ticking toward a horizon where even atoms surrender. To grasp this is to stand before infinity, where human lifetimes are no more than sparks against the eternal night. But within that vastness lies the possibility of resistance. Could knowledge itself be the lantern that pushes back the dark? Might science, our most powerful tool, hold answers to surviving the death of time? Join us as we journey into the deepest frontier, where physics collides with destiny, and where the fate of everything rests on a question both terrifying and beautiful. Can science save us from the end of time? The universe has always carried with it a quiet inevitability. Stars flare into brilliance, only to burn out. Galaxies collide, merge, and drift apart. Even the atoms that shape our bodies are destined, one day, to fall silent. But what if the story of existence is not infinite, but finite? What if there comes a moment when not just the stars, but time itself, reaches its final chapter? Imagine standing on the shores of eternity, watching as the very fabric of reality begins to unravel thread by thread. It is here, at the boundary between what is and what will never be again, that science dares to ask, must the end truly come? In the cold silence of deep time, we find the outlines of fate already written. Stars consume their fuel and collapse into ashes. Black holes, those cosmic engines of destruction, eventually fade, evaporating in whispers of radiation. The universe stretches thinner, colder, darker, until even the faintest glimmers vanish into an endless void. The end of time is not a single cataclysm, but a long, drawn-out silence, a death not by fire, but by erasure. And yet, against this vast inevitability, humanity clings to a single possibility, that through understanding, through science itself, we may find a way to endure. Could knowledge become our ark across the flood of oblivion? Or will even the brightest insights flicker out, powerless before eternity? To understand what we face, we must first look back, not in centuries, but in cosmic ages. Time, as we measure it, is young. The universe has only existed for 13.8 billion years, a mere heartbeat when set against the unthinkable expanse of what may still come. Imagine the cosmos as a vast clock, its hands sweeping not in seconds, but in eons. On that clock, humanity appears as less than a spark, vanishing almost before it is seen. Yet even in this brief flicker, we dare to peer forward, to ask what lies at the far end of the dial. Cosmologists have charted possible destinies, a universe collapsing inward in a fiery implosion, or one that expands forever, growing colder until it drifts into silence. Both visions are terrifying in their scale, each stretching beyond the reach of our imaginations. When we think of endings, we picture crumbling empires or fading suns. But these are endings only of chapters. The true end would be the closing of the book itself, the moment when not just matter, but time ceases to flow. What force could stand against such inevitability? What tool could reach beyond the pull of entropy, beyond the silence of collapsing stars? The first answers may lie in forces that surround us even now, unseen, shaping the fate of everything without our awareness. Invisible, yet omnipresent, the laws of physics are the scaffolding of reality. Gravity binds galaxies across unfathomable distances. The strong and weak nuclear forces govern the heartbeat of every atom. Electromagnetism carries light itself, the messenger of the stars. These are not just abstract principles. They are the threads of existence, weaving the cosmos into form. And yet, the same forces that give rise to life also whisper of its eventual undoing. Entropy, the tendency toward disorder, is the hidden current beneath it all. Like a fire that cannot be reignited once the wood is gone, the universe is driven toward greater and greater states of chaos. Stars shine only because they burn fuel, and burning cannot last forever. Even black holes, once thought eternal, reveal a slow death through Hawking radiation, evaporating over inconceivable stretches of time. The cosmos is not a perfect machine. It is a story with a beginning, and, it seems, with an inevitable end. Still, science has taught us that inevitability is not always absolute. We have seen old assumptions overturned before, impossibilities redefined by discovery. Could there be hidden forces, not yet grasped, that offer cracks in the wall of fate? Forces that might one day allow us not just to witness the end, but to outlast it? If we search for cracks in that wall, we are led to the most extreme corners of reality, places where the universe bends and the rules we know begin to unravel. Black holes, once thought to be devourers without escape, now appear as paradoxes of creation and destruction. Within their depths, space and time are twisted into forms our minds can scarcely hold. To peer into a black hole is to glimpse both the triumph and the fragility of physics itself. Here, in the darkness, lies a possibility. The same event horizons that mark boundaries of no return may also conceal pathways, gateways predicted in equations, though untested in reality. Wormholes, shortcuts through space-time, remain speculative, but tantalizing. Could they be nature's own escape hatches, hidden in the folds of the cosmos? If the end of time approaches, might these corridors offer us a road beyond? And black holes are not the only clues. Dark energy, an unseen force accelerating the universe's expansion, may hold secrets more profound still. It is the silent hand guiding galaxies apart, rewriting the final chapters of cosmic history. But what is it, truly? A fuel for survival, or the very architect of our undoing? Dark energy is the greatest enigma of our age. It makes up nearly 70% of the universe, yet it cannot be touched, seen, or directly measured. We know it only by its influence, pulling galaxies farther and farther apart, quickening the expansion of space itself. Like an invisible tide, it is sweeping the cosmos toward a future we can scarcely imagine. If this expansion continues unchecked, stars will drift beyond one another's reach. Night skies will grow emptier, constellations dissolving into blackness. In trillions of years, a lone observer might find themselves beneath a sky without stars, a silent firmament devoid of memory. And if dark energy grows stronger still, the universe could be torn apart atom by atom in what physicists call the Big Rip, a dissolution not just of worlds, but of matter itself. Yet, within this terrifying prospect lies a paradox of hope. For if dark energy can reshape the destiny of the cosmos, then perhaps it can also be understood, harnessed, or redirected. Could the very force that threatens to scatter existence be transformed into a tool of survival? Or is it the reminder that some mysteries, however profound, are written to remain unsolved? Throughout history, humanity has stood before the unknown and refused to look away. When ancient stargazers first traced patterns across the heavens, they could not have imagined the physics beneath those pinpoints of light. Yet their curiosity planted the seeds of modern cosmology. Centuries later, Newton revealed gravity's law, Einstein bent space-time with relativity, and Hawking gave voice to black holes. Each discovery tore back the veil of mystery, showing us that even the most incomprehensible truths can be brought into the light. But with each step forward, the horizon only retreats. For every mystery unraveled, new ones emerge, larger and more daunting than before. We are left not with answers that bring closure, but with deeper questions. Is time itself a substance we might bend? Could new physics beyond our current grasp rewrite the story of entropy? Might the very constants of nature be less constant than we believe? The drive to ask such questions is more than science. It is survival. If knowledge has saved us from extinction before, shielding us from famine, disease, and darkness, might it also be the shield that guards us against the death of time itself? Or are we reaching for a salvation that lies beyond human hands? To imagine our survival, we must stretch thought beyond the boundaries of Earth, beyond even the lifetimes of stars. Some theorists have envisioned civilizations that do not merely inhabit the universe, but engineer it. Vast structures that drink directly from the light of suns, networks of intelligence woven across galaxies, minds uploaded into artificial substrates, no longer bound to fragile biology. If entropy is the current, could consciousness itself learn to ride its flow rather than be drowned by it? Others whisper of stranger strategies still. Could we migrate into alternate dimensions, if such realms exist? Could we create pocket universes, artificial bubbles of space-time, where time begins anew, safe from the dying embers of this cosmos? These ideas hover between science and speculation, yet they serve a purpose. They remind us that survival may require imagination as bold as the universe is vast, and if even these paths fail, perhaps the final refuge would not be in matter at all, but in the preservation of information, the blueprint of life, mind, and memory carried forward into whatever lies beyond. But what, truly, awaits us on the other side of time's collapse? Push the vision further, and the scenarios grow almost unbearable to contemplate. Picture a universe stretched into eternal expansion, where galaxies vanish beyond reach, where even black holes fade into whispers, and where the last particles themselves decay into nothing. This is the heat death of reality, an ocean of endless darkness, flat and silent, where time has no measure because nothing remains to mark its passage. In such a place, survival seems impossible, even laughable. Yet it is precisely against this horizon that science tests its greatest strength, the refusal to surrender. For every doomsday written into physics, researchers search for loopholes. Could quantum fluctuations spark new universes from the ashes of the old? Might the death of one cosmos serve as the birth cry of another? The multiverse theory suggests infinity itself may be the ultimate escape, that somewhere, beyond perception, another dawn always waits. But if that is true, can we ever reach it? Can we carry ourselves, our histories, our fragile spark of awareness into those distant realms? The end of time may not be a wall, but a doorway. The question is not whether it will open, but whether we will find the courage and the knowledge to step through. And so we return to the most haunting truth of all. Science may never halt the march of entropy, but it may teach us how to meet it. Perhaps our legacy will not be in fleeing the end, but in shaping what end means. If time itself is a canvas destined to fade, then our discoveries, our stories, our very act of questioning are brushstrokes that linger against the dark. We cannot yet say whether humanity will endure beyond the dying of the stars, or if we are a brief flame that burns brilliantly before silence. What we can say is that knowledge has always been our defiance, each equation, each theory, each fragile experiment, a refusal to bow to inevitability. Even the search for escape is itself a form of survival, proof that we are more than passengers in the universe. We are its witnesses, and perhaps, in some hidden way, its authors. And if the end of time is indeed written, then let it find us reaching still, daring still, imagining still. For in that defiance lies the truest mark of what it means to be human.